Okay, so let's look at this question here on atomic structure. It reads, they're saying calculate the energy required to excite the hydrogen electron from the Lyman series to the Balmer series. Okay, so how can we calculate the energy there? So we have to understand three things there. We have to know what is the meaning of the Lyman series, and we also know what the Balmer series are. And then we also have to know the formula, okay? The formula that we should use in order to calculate that energy when the electron moves from the Lyman series to the Balmer series. Okay, so let me go to my board here. So we know that an electron can gain energy to move to another energy level. So if I draw this as my representation of a certain atom, okay, so these circles I'm drawing here are what we call as the energy levels. Okay, so if I have a representation of this certain element as this, and then I have an electron somewhere there. Okay, so this is the first energy level. So we say this is N is equals to 1. Then the second one we say N is equals to 2. The third one we say N is equals to 3, just like that. Okay. So an electron in the first energy level here, it can gain energy and then it can jump, okay? It can jump from this first energy level, it can jump to the second energy level here, or it can even jump to the third energy level there, okay? So an electron, if it gains energy, it is able to do that, okay? It can jump to the second energy level, it can also jump to the third. Similarly, if I have an electron in the third energy level, or whatever energy level it may be, this electron here can lose energy, okay? Then what happens when it loses energy? It drops to a lower what? Energy level. Okay, so these are what we call as the transition. It can move from a lower energy level to a higher one, or from a higher one to a what? To a lower one. Okay, so now on those on that question there, we saw the word Lyman series, Balmer series. So what does it mean? Okay, so when we talk about the Lyman series, we just simply means Lyman like this. Okay, so whenever you see a Lyman series, it just simply means the N value there is what? 1. So it means the energy level is 1 if you see Lyman series. If you see Balmer series, okay, if you see Balmer series, it means they're talking about the energy level number what? Number 2. And then what other series do we have? Okay, so from the Lyman Balmer series, we also have what we call as the past chain. Okay, so the past chain is like this, and this is associated with energy level number what? 3. Okay, and then we also have the bracket. Okay, we also have the bracket. So this bracket here, it's associated with energy level number what? 4. And then we have the P fund. Okay, we have the P fund, which is associated with energy level number what? 5. So whenever you're given a question, they won't specify the energy level here. They'll just give you the series. So if they say Lyman, always guys, the energy level is number 1. Okay, so in that question, we have a transition from the Lyman series to the Balmer series. So meaning we are moving from the energy level number 1 to the energy level number what? 2. That's what we are doing there. Okay, so now how do we calculate the what? The energy. So you have to know this formula. So you say the energy of an electron when it makes a transition. In fact, you say the change in energy when the electron makes a transition is equals to minus 2.178 multiplied by 10 to the power minus 18. And then in the brackets, you're going to put 1 over the final energy level indicated by NF squared, then minus 1 over the initial energy level squared. So this is the formula that we are going to use to solve that question. So remember, they said the transition was from what? Was from the Lyman series to the Balmer series. So meaning it was from the energy level number 1. So our initial energy level will just be 1, and then we are going to the final energy level, which is what? 2. So we know that this one is layman here, and then this one is what? Wow. Okay, so master those things. Okay, so we're just going to replace. So where there's NF here, I'm going to put a 2. Where there's NI, I'm going to put a what? A 1, for me to find the change in energy as the electron makes a transition from the Lyman series to the Balmer series. So we are going to say the change in energy is actually equals to minus 2.178 multiplied by 10 to the power minus 18. That should be 18. Okay, so this is 18. And then in the brackets here, I'm going to have 1 over, what was our n final? It was 2 squared, then minus 1 over 1 squared, like this. Okay, and then from here, what do? We say minus 2.178 multiplied by 10 to the power minus 18. And then we solve what we have in the brackets here. So here we have 1 over 2 squared, which will just be 1 over 4, then minus 1 over 1. So this will be the same as 1 over 4 minus 1. Okay, so 1 over 4 minus 1, it will give us a minus 3 over 4. Okay, and then you multiply this number here by the number that you have here. So you multiply in a systematic way, okay, so that you don't get confused. Don't put all this number on your calculator. So just concentrate on the decimal number there. Forget about this guy. So we're just going to get this number, okay, multiplied by a minus 3 and then divide by 4. So when I punch that into my calculator, I'm getting my 1.663, and then we can now add this guy here. So multiplied by 10 to the power minus what? 18 joules. We know that energy is in joules. So this is the energy, okay, that is required for a transition to happen from the Lyman series, which is just N1, to the what? To the Balmer series, which is what? N2. Okay, so this is the change in energy. So we've answered the first question. And then let's look at the other question. So the other question, they're saying also calculate the wavelength of light that must be absorbed by the hydrogen atom in its ground state to reach this excited state. Okay, so ground state is just the energy level number 1, which is associated with the Lyman series. Okay, so how are we going to calculate the wavelength? So we know that the change in energy, okay, can also be given by this formula, which is Planck's constant multiplied by the speed of light divided by the wavelength. Okay, so we can make this wavelength the subject of the formula. So we are going to say over 1 cross multiply. So this multiplied by this, we are going to have this change in energy is equals to HC. Okay, and then we can make this guy the subject. So this will just be what? HC divided by the change in energy. Okay, so HC, guys, this H here is what we call the Planck's constant. And then C is just the speed of light. We all know the value of speed of light. So H is a Planck's constant. So it has a constant value of 6.626 multiplied by 10 to the power minus 4. So you just have to know this one. And in some cases, it is given in the test or the exam. And then the C, we know that is 2.9999. We can just round it off to 3.0, then multiplied by 10 to the power what? 8. So this is the speed of light, and then this is Planck's constant. And then we also know the value of this because we are from calculating it here. Okay, so we can substitute these 3 values to get our what? Our wavelength. So our wavelength will be equals to Planck's constant, okay, multiplied by 10 to the power minus 34. And then we are multiplying this with the speed of light, 3.0, multiplied by 10 to to the power 8. Then we're dividing all this by the change in energy that we found was 1.633 multiplied by what? 10 to the power minus 18. Okay, so you can punch these values now into your calculator for you to find the what? The final answer. Okay, so make sure that you put these brackets here when you're punching this value into your calculator. So when I punch this value into my calculator, it's giving me 1.216 multiplied by 10 to the power minus 7 meters. Okay, because wavelength there is in meters. Okay, so this is our wavelength. So this was our question 2. And then our question 3 now states that, what is our question 3? So our question 3 here, they're saying what type of radiation is associated with this transition. Okay, so for you to know what type of radiation, you have to look at the value of the wavelength that you have. So depending on the value of the wavelength that you have, okay, it will tell you the type of what? Radiation. Okay, so I think let me give you the ranges. So we have 7 electromagnetic waves, right? So we have the radio waves, microwaves, infrared, we have visible light, and then we have ultraviolet, we have X-rays, and then we have the gamma rays. Okay, so all these have different ranges for the wavelength. Okay, so for the radio waves, the range for its wavelength, okay, is any number that is greater than 10 to the power 9 what? Nanometers. So if you find your wavelength is 10 to the power 9, or it's a number that is greater than this, you say that the type of radiation is what? Radio waves. Okay, so here we can say anything greater than this, greater than or equal to this, is a radio wave. And then microwave range from, okay, so microwave range from 10 to the power 6 nanometers all the way to what? 10 to the power 9 nanometers. Okay, so anything in between these two values here, when they ask you what type of radiation is this, after you found the wavelength, okay? So if it's in between these two numbers, then it's a microwave. And then we can talk about, so microwave, okay? So we can talk about infrared. So infrared has this range, okay, from 700 nanometers to what? To 10 to the power 6 nanometers. Okay, and then we also have visible light. Okay, so visible light in itself, it also has a spectrum inside, a spectrum of colors, those colors that you see on the rail. Okay, so the visible light one ranges from 380 nanometers to 700 nanometers. Okay, and I must state that it's also important to know the wavelength of each color in the visible light spectrum. Okay, but I won't give them here. If you want them, they are there in my notes. The notes are on the drive. When you register, you'll be given access. Okay, and also a full topic video on this same concept. Okay, and then we go to the ultraviolet. Okay, so ultraviolet has this range. It has from 10 nanometers to 380 nanometers. Okay, so that is the range for ultraviolet. Then X-rays. X-rays, it's from 0.01 nanometers to 10 nanometers. Okay, I hope you are getting, you're seeing how the ranges are going. And then we have finally the gamma rays. Okay, so the gamma rays is anything that is what? Less than, anything that is less than 0.01 nanometers. Okay, so if you find a wavelength that is less than this, you're going to say that radiation is a gamma ray. So now let's go back to the to the wavelength that we found. Our wavelength was this. Okay, so we found this as our wavelength, and then we have been asked to state what kind of radiation it is. So we notice that this radiation here is in meters. Okay, so always you have to change your wavelength from meters to nanometers. Okay, so how do we change this guy to nanometers? Okay, so we change this guy to nanometers by just simply saying multiply by 9. So we are going, or not multiply by 9, by multiplying by 10 to the power 9. So this will be 1.6126 multiplied by 10 to the power minus 7, and then multiplied by 10 to the power 9. Then this will now become nanometers because I've introduced this guy here. So you see that this guy is of the same base, so it will be 1.216 multiplied by, we just add minus 7 plus 9, so this will be 10 to the power 2 nanometers. Okay, and then 10 to the power 2 is just 1,000. So meaning if I multiply this number by 1,000, I'm just going to move 2 decimal places, 1, 2. So meaning our 121.6 what? Nanometers. Okay, so now once you have your wavelength in nanometers, okay, you go back and check on the ranges. So it means you have to know those ranges, okay? So I have 121.6 nanometers. So in which range can we find that? Can we find it in the radio waves? No. Microwaves? No. Infrared? No. Visible light? No. Ultraviolet? 10 nanometers to 380 nanometers. So meaning that 121.6 nanometers. Okay, it will be in between 10 and this 380. So we can conclude that our radiation, because the wavelength is between 10 and this, will just be what? Our radiation will be ultraviolet. Okay, so ultraviolet radiation. Okay, radiation. So that's the answer there. All right, so thank you so much. Those who want to register with our academy, you are welcome to register. Just inbox the number in the comments below. Okay.